All right, ladies and gentlemen, our last two problems in section 5.3 involve sketching. Now, this equation is written in exponential form. We're asked to sketch it, which means we eventually need to be able to type in y equals, so I need to have this y by itself, okay? Couple ways to do this. Let's see which way I want to teach it to you. I think we'll do that. Let's do this way. This is currently in exponential form, okay? We want to put it in log form, and I'll show you why. This would be the log. Okay, the base was 6 here, so it's log base 6. And remember, when you're converting to log form, the exponent always goes alone. So it would equal y, and that means the x would have to go here. Well, look at how cool that was. When we converted it from exponential form into log form, it automatically got y equals. So now we can type this into our calculator. And to type this into our calculator, we're going to apply the change of base formula. So this is the natural log of x divided by the natural log of 6. Or the log function, common log will work also. So, when I go to y equals, I type in the natural log of x, I close parens, divided by the natural log of 6, and I close parens. So there we have the natural log of x divided by the natural log of 6, and we hit graph. And there is our logarithmic function. Actually, we just graphed y equals log base 6 of x. We know that the y-axis, which is the line x equals 0, serves as my vertical asymptote. So the graph drops off here very quickly, and then you can see it crosses the x-axis and slowly climbs upward. So that is my picture. Showing the vertical asymptote helps immensely in knowing how to read domain, range, as you've seen in past videos. Okay, one last graph. Suppose I want to sketch x equals 1/3 to the y power. Okay, same thing that we just did up here. This is in exponential form. If I convert it to log form, this becomes the log base 1/3. Remember, bases can be positive numbers not equal to 1, so fractional bases are fine, you know, like numbers less than 1 but greater than 0. Okay, and this is equal to, the exponent always goes alone. It's the answer to the log function. That means this has to be x. So I've converted this into log form. And then, of course, to graph this in my graphing calculator, I'm going to need to write this as the natural log of x divided by the natural log of 1/3. So let's go ahead and type that in. Y equals, let me clear out what I have in there now, and we're going to type in the natural log of x divided by the natural log of, and I'm going to, see, it already gave me one paren, I'm going to do 1 divided by 3, close paren, there we go, and hit graph. And what's actually happening here is we still have a log curve, but this time, when I'm drawing it, even though the line x equals 0 is still my vertical asymptote, the graph goes, it hovers this way. So the graph goes this way, crosses the x-axis, and heads over and down. Okay? Again, I want you to notice the difference. When a log function has a base that's a number greater than 1, it's going to have this basic shape. When a log function has a base that's between 0 and 1, the shape is basically a reflection with respect to the x-axis of what the normal, quote, normal shape would look like. And again, if you just trust your graphing calculator and you convert from exponential form to log form, then use the change of base formula, you're going to nail the graph every time. Okay, this is the end of section 5.3.